these are the three guys, together with Tommy Svensson, supporting you this morning. Joel and Janne and Tommy are your local technical support. My name is Kai Bussiek. I'm located in Duderstadt in the headquarter as a kind of product manager, but with a CPO background, so kind of technical product manager. I somehow founded the area of soccer technologies at Ottobock 25 years ago. So I'm quite long with the company. And in the meanwhile, I'm more involved in development and in research for the next 10, 15 years. We think about what happens in the next 10, 15 years, or what will come out in about 10 years' time or something like that. So that's my current part. Today, we simply talk about liners. You all know that when we talk about liners, usually we also have to talk about suspension, because only the combination of a suspension and a liner makes sense. In this case, we are focused now on the liner. We have 4 different points on the agenda, which is the liner portfolio at the beginning, and then we are focused on this new Skeo Sealing family, and then we have this Q&A session at the end. I hope I'm still on air and nothing happened so far. Can everyone hear me still? Hello?
Yes, Kai, we can hear you.
Okay, thank you. Okay, so that was just a double check. So, okay, let's start with the liners. Ottobock portfolio is known as being quite complex. The question is a little bit why. So we try out to find a way, or we try to find a way to make it less complex, but obviously it cannot be the number of the products we have in our portfolio, because if you see that, we are the one with the lowest number of liners if you compare the 2 and the 3 main players in the world. So there should be something different. We are eager to learn what should be changed. That the way of our catalog is that the way of the presentation. So would be great if we could get your feedback. Please support it to Joel, Tommy, and John, and also Janne, and that we are able in the future to change anything. Before we step into the portfolio itself, short introduction of the 3 liners, what we have on the market. So we are the only company really supporting with all 3 main liner materials on the market, which is the Skeo. These are the all the silicon liners. You all know silicon very well. And because Europe is mainly the silicon market, Kaleo is, or let's say copolymer is increasing at the moment, but most liners being fitted in Europe are silicon. This is different in America. There you have more the TPE liners and the polyurethane liners. So silicon, you know that very well, is really supporting with a good hygienic factor. It's easy to clean. The biggest thing is the compression what you have. So this leads already to when should I use a silicon liner. So compression gives you a certain shape of the residual limb. So it's best to use residual limbs with quite a good soft tissue coverage and not that much these bony and really prominent residual limbs. So Kaleo is our TPE liner or copolymer liner. This word is has something, has a certain background. So Kaleo comes from calor. Calor is Latin and means heat. And as you can see that, all the TPE liners on the world market, also ours, are thermoformable. So you can change the shape by heat in a certain way of doing that. This is described in the IFU. Of course, the textile on the outside is something which limits this change or restricts this change in a certain way. So don't think about having a custom liner after doing the thermoformable process. It's just a little bit changing the shape due to the restriction or limitation of the outside textile. Yeah, and Uneo is the last big family of our liners. These are the polyurethane liners. We call it Uneo because it's really a unique liner, supporting really with very, very good pressure distribution, supporting with a high amount of comfort, and also from the, so I like this liner because this liner tells me if the liner is cracking, this liner tells me what's going on in my socket. So I can just change the socket design just based on the fact what the liner tells me. And this is why I really prefer this kind of liner, because this liner has an expressive language, and I can solve a lot of problems without having the patient in my workshop, just by having a WhatsApp or email or telephone call or whatever. And whenever the patient needs to come into the workshop, I have already solved 80% of my problems, and I can really stick to 20%. This is what Uneo can do with me. This is not able with silicon, so not able with the Skeo liners, and just partially with all the TPE liners. So how do I select my liners? Of course, I mean, for most of you, this is nothing new. It's just to bring it up into your mind again, how simple the way it is to really select liners. This is based on anatomy, soft tissues versus bones, and the shape, of course. And then I can really think about the material specifications. I can think about geometry, so whether I need a conical or a more standard version, whether I need a locking or a cushion version. And if you get to the TT portfolio, you all know, again, it's simple, but it's really worth to have a certain look at it, to really think about it, and to make it visible again. So we talk about two bones and just some little amount of muscles around it. So mostly we have very prominent, very bony residual limbs, not that much soft tissues coverage in most cases. And so that is a little bit also influencing, or this is influencing the liner material. So we need a liner which is serving as cushioning, as patterning. So best perhaps if it's very bony, pressure distribution. So we speak more about gel liners, what you hear very often. And these gel liners are mostly copolymer and polyurethane liners. And this is also something what you see in the world, that most of the TT residual limbs are really fitted with softer materials and less with silicone liners. And then you need to look at cushion versus locking. I'm an absolutely believer in cushion liners and vacuum fittings. And all my patients are running on a vacuum, doesn't matter whether it's passive or active. And I have absolutely no locking version anymore, for a very simple reason. The guys from Respector, they have shown it to me many, many years ago. They do all their fittings with a thermal imaging camera. And what is in common with all these TT fittings having a locking system is that the limb at the distal end, or the stump at the distal end, is very cold. Whereas when you have a vacuum system, the temperature within the residual limb or within the stump is more homogeneous. And this has absolutely, yeah, let's say, I was on a vacuum system even before that, but when I saw this picture, I was on the way out, yeah, you're doing the right thing, and delete locking systems and insist more in vacuum, one-way valve, and active systems. So yeah, when you talk about TT, sometimes you have good soft tissues coverage, then it's worth to think about silicone cushion liners, or if you still are addicted to locking, use locking. I would use a cushion liner, but the focus in TT is really on TPE and polyurethane. And when it comes to TPE liners, so to copolymer liners, you need to think about whether I can get from the reimbursement system 2 liners per year, or whether I'm only able to get 1 liner per year. In Germany and US, for example, we get 2 liners per year. That means every 6 months we can use, we can order a new liner for our patients. And that's why TPE is quite interesting, because the softer TPE liners from Willowwood, for example, and also those 94, 95, 93 liners, so 6Y93, 6Y95 liners from Ottobock, those are the softer TPE liners. They worn out more quickly than, let's say, TPE liners being a little bit harder, like the 6Y90 and the 6Y92 from Ottobock. So we have two TPE liners mainly in our portfolio. The one is really the soft one, which is meant to be used when you have 2 liners per year. And the harder ones are known for having a longer lifetime. There you just get 1 liner per year. So this is experience from the world market. There we differ a little bit in TPE. In Germany, we have the luxury to get 2 liners per year to the patient, so we are on the softer TPE liners. And yes, then they have the polyurethane liners at the end, which has a lifetime. So I would say an average lifetime of 9 months. I have some patients running much longer on those kind of liners, sometimes even 1.5, 2 years. But what restricted this liner material is that it can absorb water, that it can absorb liquid, so it starts to smell bad. Even if you clean it very well, it starts to smell bad just because of this behavior. You can not eliminate this by using the skin guard version. Skin guard version is really something where you protect the liner from bacteria, but not the residual limb. We don't want to change the flavor, or we don't want to change the surface of the residual limb, so the bacteria surface on the residual limb. So skin guard is only protecting the liner and is not coming to the residual limb. I'm a fan of this kind of fresh liner when it comes to polyurethane. This is an ingredient having a fresh scent. So the scent is from Dove. You probably all know this brand, this hygienic brand Dove. So that's the flavor what we have in some liners. Maybe some of you might smile a little bit. My patients insist on this liner because it really smells good. So when you have your shower and get on your polyurethane liner, it feels and it smells fresh, and you don't have this smell of a liner in your nose. And this is especially for polyurethane, because polyurethane is really this one where, as I already told you, where it absorbs water and where the smell is changing. So in TF, it's a little bit different. We just have one bone, a lot of soft tissues coverage around. So there you only need to think about cylindrical versus conical. And of course, because of this good soft tissues coverage, we almost can use liners having a little bit more compression capabilities. So in order to make a better cast or a better scan, so definitely you're with a silicone liner, so with Skeo liners at Ottobock. And there you only need to think about the standard, or at Ottobock we call it 3D. So the 3D liners are the conical liners at Ottobock, because we change the geometry based on the anatomy in 3 dimensions in most cases. Very quickly over this is something how I decide about my liner and my suspension mode, and I have a kind of hierarchy. So the most important thing is the reason for the amputation, and of course the level of the amputation, because when I have a TT amputation, I don't need to think about an artificial knee joint. This is simple, but it's the first decision what I have to make when it comes to socket design. And then I think about all these collateral diseases, which is very important when you think about diabetes vascular disease patients, for example, that you think about all these comorbidities around it and find an answer on all these comorbidities around it. And then I have the last circle, which are the requirements of the end user. And it's not that the end user just listed his or her requirements. It's more about prioritization, and I try to really fulfill the top 3 or top 4 requirements of the end user. But the 2 inner circles are based on health, so that's a little bit more important for me. And then I really discuss requirements with the end user. And I strongly ask them to really prioritize. Just listing up is not an option. I want to have a prioritization. Well, that's how I personally decide about my way of doing the fittings, just as a kind of proposal. Yeah, this is something what you can get from the Scandinavian market, from your local marketing, Ottobock marketing department. This is a liner portfolio poster being valid for the whole Scandinavian market. This is way too small in order to read something, so please feel free to order those posters for your workshop. Coming to the main point, which is, sorry, which are the Skeo Sealing, is the Skeo Sealing family. So starting with TT again, a very short introduction. So for those of you, by the way, who are already ordering this kind of Sealing TF liner, which we have on the market since 2016, this liner is basically the same, only in the dimensions for a TT. So we have a textured inner surface, which we have on our silicone liner since many, many, many years. Which reduces this high adhesion at the beginning of every silicone liner, and feeling a little bit more silky, feeling a little bit more comfortable. Then we have, based on the fact that most of the residual TT residual limbs are somehow planned amputations, and these amputations have a residual limb length of 12 to 15 centimeters usually. So that's why we just play with one ring height or sealing ring height. There is no option for another one, because if you think about where the popliteal trim line is coming from, your residual limb length minus the popliteal trim line, and then you need to have this ring somehow inside the socket, so 2 or 3 centimeters below the popliteal, then you are exactly there where we have this ring height. So based on the residual limb length, it's only able to offer one ring. That's why we have done so. It's easy to clean and dry, obviously, because there is no textile on the outside. This is what most of our patients are really stating, what they really see as a big advantage, that they can clean the liner, and immediately after cleaning and drying, they can don the liner again and use it within the prosthesis. Makes it a little bit more comfortable when you're let's say going out for a swim or something like that. That you are able to not change the liner, not having a second liner with you, but just cleaning the liner inside the building you're in. Less limitation during flexion. Yeah, this is quite obvious. I personally think the most benefit what you can do in order to make bending or flexion more easy is something what you can do with your socket design. So how do I create my socket? How do I create my inner part of the socket? Do I take care of the femoral condyles coming to the front when you flex your knee? But definitely the knee sleeve has a certain influence. It's, to my opinion, it's a minor influence. It's not that much, but the world market is really asking for such a liner, and that's why we have done it several years after Earthro came out on the market. This is just based on the patents which are out. Patents are out now. Our patents are done now, and that's why we could come on the market with our own liner. Wall thickness progression just only means that the wall thickness is thicker in the distal part, thinner in the proximal part, so you have a tapered version of the liner, and make it more flexible and more comfortable at the upper part. Of course, in a TT liner, you just have a partial matrix and not a complete matrix. And we have this kind of CVD coating on the outside, which is a smooth outside cover. On silicone, I've made the experience that it lasts quite a long time. We have not that much. We have some minor complaints that the CVD coating is going apart from the liner, but this complaint rate is something like 0.05, 0.06% of all complaints. So it's really something where we don't need to think about. This is more important when we think about polyurethane liners, that the CVD coating is not working that well as we hoped for. And then there is, of course, as Ottobock has a TT valve, which is automatic. We couldn't use this TT valve together with our sealing liners because then you could only don the prosthesis and never would come out of the prosthesis anymore. So we had to develop a small and little expulsion valve, which can be opened manually. So this expulsion valve can be used for all amputation levels except hip disarticulation and higher concerning the lower extremity. It's quick and easy to install by the CPO just because of its 10 millimeter thread. So it's basically the same as the ice lock, the ice frost locking 510. The thread, the length of the thread is made from plastics, not from metal, and it's shorter, and that you don't need to cut it, but just having the appropriate length. It has to be combined with a liner. This is mentioned within the IFU, and this is the simple reason is that the length of the thread has not necessarily the same length as the thickness of the socket. So it might be that the length of the thread is somehow shorter than the thickness of the socket if you have a 12 or 15 millimeter thermoline socket material, for example. And as this is not ending right on the same level as the socket itself, the precondition is that it has to be combined with a liner, and also the opening is not that small that enough air can go through. So when you would use this valve just without a liner, you might have a kind of hickey or red skin coloration at the residual limb itself. So when you have a liner, doesn't matter because liners are in that area mostly 5 or 6 millimeters thick. So it has nothing. There is nothing worse with the skin. Yeah, a little bit more. Some more details on the valve itself. You see two markers on the valve. This is the basement here with the 10 millimeter thread, which you just screw into the socket, glue it. So I usually glue it with silicone bonding agent when it comes to a check socket. I do it with super glue when it comes to the definitive socket. And you're able to, you get this valve in a disassembled way. So you get it in two parts because first you have to thread this into or screw this into the socket, and then you apply the top cap or the how we call it here, the cover. And it's important to have a look at these two lines, this one and this one. They need to be connected to each other. They need to be in one line, and then you can press this cover onto the basement and turn it a little bit. The cool thing of this valve is really turning, and so you can open and turn it just by, you can open and close it just by turning. So here you see the lockings when it's locked and dislocked or opened. When you lock it, you have a kind of tangible signal, which is not that much hearable, but more feelable if you lock it. This makes it even interesting for people like, so we have one sales rep out there. We have one sales rep out there you opening the valve when he sits inside of the car and driving the car, even if he's fitted with just a simple one-way valve, just with this valve here. But he loves to open it during driving because then he has a little bit more comfort within his socket and can easily bend the knee. So and that makes it interesting for those asking for something like that. When it comes to a harmony fitting, for example, you can easily apply this in addition to a harmony, just like a second hole in the socket. Apply this valve, and then patient is, or the end user is able to open it during knee flexion, during sitting in a very restricted area or very limited space limited area or something like that. So it's waterproofed, even with salt water and chlorinated water. So you can use it even in your bathing prostheses. It's easy to clean because people, even the end user, they can open this, they can disassemble this valve whenever they want to do that by cleaning the valve itself. So you can disassemble it by turning and pulling a little bit, and then you can get the upper part away from the basement, and then you have a direct view onto the valve, and you can clean the valve just by water or just by air or whatever. And that's very easy, and you can easily see that. Yeah, that's our valve. These are the SAP codes when you want to order it. And then we quickly jump to the TF version. So the TF version, we have a standard version, which is out on the market since 2016. And we recently, beginning of this year, we launched the 3D version, which is definitely a combination of both. That's why it's not a real conical version. It's something different, whereas you have a kind of geometry on the standard version, which is quite strange, oh, I missed the English word, sorry, but you see this blue line, it's just one line showing the geometry. So the 3D version has a more conical area, which is the distal third, and a more standard area, which is the proximal 2/3. And we did that because we did some data investments, and we looked at 7,000 TF design datas. TF design are these kind of electronical created test sockets at Ottobock. So you can order these kind of test sockets, and this is created within our IFAB. You only need to put in some measurements and some data, and based on these data of 7,000 TF design sockets, we have created an average residium shape, and the answer was this kind of liner. So a real conical liner is just pushing the soft tissues a little bit upwards, and at a certain time it's somehow part of the liner. This liner, because of this more standard version at the top end, encloses the soft tissues and keep the soft tissues in the distal part, and that makes this liner so interesting. So it's more a combination out of a conical and a standard version, as you can see. The distal third is more conical, the proximal is more standardized. Basically, it's the same liner as the TT. So we have, again, the textured inner surface. Here we have two different sealing heights, 10 or 17 centimeters. It's the sealing ring is pre-produced or pre-attached to the liner. You're not able doing this by yourself. And yeah, we have again this thin wall progression like in the TT version. In this case, of course, as we are in TF, we have a full length matrix inside, smooth outside as the other one. So the only main difference is really the matrix, what you see here. TT, it's obviously only below the knee. In TF, we can have this over the full length of the liner. SAP codes, again, for your reference, you'll get this presentation later on as a PDF file, so you can look at the PDF at the SAP codes or ordering codes in a more detailed way then. So the question is always, when should I use either the 3D or the standard version. And this is something what you know already from Össerer. We have done that according to our liners. So, and we have, on purpose, we have chosen the same process, the same diagram, for a very simple reason, that you don't need to really dig into that diagram. You know that part from Össerer, so it's easy for you to read. In addition to that, we will do something in the near future. We have already ordered those. Every liner, every TF liner, and we start with the sealing family, will have two of these kind of strain indicators. These are two T's laying on the side, having a distance on the liner of 35 millimeter. When you don this line, and we have it on the proximal part and we have it on the distal part of the liner. When you don the liner, you pre-stretch the liner. So these two T's are getting apart from each other. If this is not the case, you know that there is no compression on the liner, and either the shape or the size of the liner is not correct. If this is more than 45 millimeter away from each other, then you know the pre-stretching of this liner is way too much and the size or the shape of the liner is not correct. So you want to have a distance of these two teeth from each other somehow between 38 and 44 millimeters. And with that, you can easily decide whether you need to use a standard version or a more conical version. So if you have a standard, so 6x110, which is the standard version, and you have this correct dimension here, but here it's something like 50 millimeter, you know, okay, the standard version is not correct. I need to have the 3D version. Mostly you reduce one size when you get the 3D version, because the 3D version is very, very conical in the distal part. So this is in preparation. I guess this will come at the end of the year. Yeah, I like this idea. We have tested a lot, and it really makes life easier for deciding which kind of liner size and liner shape you need, because this is the most important part before you really go on with your socket. The liner shape, the liner size, the liner fit needs to be perfect. Even think about custom liners when it's worth to think about and when it's worth to make it, because this everything around the liner decides the quality of your fitting later on. You don't need to do any compromises if you have a good fit with the liner itself. So that was the presentation, basically. Thank you for that. Thank you for listening. And now I think we start the Q&A session, and I would not share my screen again. Hopefully, yeah, I'm still in. Can you hear me? Perfect. So yeah, Q&A session. Any questions?
So what's the most common question you get, Kai and Joel?
I just looked through it.
I think that the explanation that Kai gave about the materials is pretty much the crux of the problem in regards to when to select the right material. So I feel that Kai gave a good explanation of the different materials and their properties, and when or when to not apply those material types. And that's probably the main one we would receive in regards to liner selection for Ottobock. So I think you explained it perfectly, Kai, and that's why we don't have any questions in the chat.
Yeah, it's I always try to do it a little bit more simple, and you really can stick to this kind of three words that when you use a silicone liner, you have compression. When you use a TPE liner, you have thermoformable. And when you use a polyurethane liner, it's just pressure distribution. These are the main things. I personally stick to the more soft liners when I have a TT fitting, and the TF fitting is definitely a silicone liner because of this kind of compression, and it makes more easy for me to do either doing a scan or plastic cast. So that's why I have this kind of rule, and this makes it easy at the end. Yeah, if there is nothing, I mean, you might 6195, which works for many patients, although it would be great if you could make 3 millimeter, maybe 9 millimeter version for some patients with volume changes, Johannes. Good idea, Johannes. Thank you for that. We have already thought about, we have a project running for a liner which is called diabetes liner and vascular disease liner, which comes on the market in about 2 years' time. So we will present this liner at the next OT World, and during second half of that year, we will launch the liner. And we really think about this when we are doing this kind of liner. What you also can think, so this would make the reason why we didn't step into this area was is quite simple. We are known as being complex, and we would even make the whole portfolio even more complex. That's why we didn't have done it so far. What you can do, and this is what I usually do, I take something like a very thin liner below it and use the normal TPE liner over it, and you get, so that is, for example, I've learned that from a guy, Pierre Chablot in France, and he's using his ProSeal system. He loves this kind of ProSeal liner, which is 3 millimeter throughout the whole liner. And I asked him, so when you lose during, and he is doing the ProSeal system even during the first fitting period, the interim fitting period, first 6 months. And I asked him, so if you lose volume and you have your lip glued into the socket, how would you deal with this volume loss? And he said, it's very simple. I use the next size smaller liner, and I have 2 liners in my socket. And that's how I work against this volume loss. So this is something where we think about this kind of modular concept, not just having a 9, a 3, and a 6 millimeter liner in the portfolio, but just thinking a little bit more about modular. Basically, yeah, good question. Basically, I know that if you have a vacuum, and if you try to get a certain permanent vacuum, then you don't have any challenges in terms of volume changes, because if there is a vacuum created, which is permanent, the residual limb has no chance to get apart from the socket. This is different when you have just a one-way valve, because the one-way valve opens in stance phase, and yes, then you obviously sometimes need to work with socks. In TF, I haven't made the experience that I don't have that much challenges with it, so I don't need any socks. That's why we don't have these kind of volume socks for sealing liners as Össur have them. Because we have made the experience that based on the volume, based on the surface adhesion in TF fittings, volume socks are not that much necessary. And if I need one, I just do it by myself. I take a normal volume sock, I cut the distal edge. First I make a glue ring, and then I cut the distal edge, and then I have the same thing. Very good. Sweat management. There are still two, and to give you a short answer, there is no real cool solution on the market yet. There are two big things which are very, very important for all our end users, not being addressed on the world market by a really good working system. The one is sweat management, and the other thing is phantom pain. Both are somehow addresses by some products, but if you look at this kind of perforated silicone liners, it works somehow, but what do you do with the water on the outside of the liner when the water is going through the liner? So you also need to disassemble the prosthesis, you need to clean the socket, and then you can assemble, or then you can don this prosthesis again. So it's not really working very well. It's working somehow. Even this kind of textile on the outside from Willowood, it's working for the first 30 minutes, then it does not work anymore. So all the solutions on the world market at the moment, I'm not really satisfied with that, even in terms of phantom pain. All these, I'm pretty sure, I can tell it for Ottobock that we are working on both topics. I'm pretty sure that all the other industrial companies are also working on that, but it's really excessive heat and sweating. There is an oil, or I always forget the name. One of my colleagues, they tried out this special kind of oil, and this guy was using the oil before donning the liner, and this reduces the sweat. Very, very expensive oil, but I forgot the name. No idea. Sorry for that. But this worked for this one guy. It's not sure that it works for every amputee person. I'm a big fan of the polyurethane absorbing by 30% this kind of sweat, but still, if this 30% are reached, you're still sweating. So there is not a real good solution. Sorry for that at the moment. It's really very, very based on experience and very individual. Yep. So yeah, I don't know whether we want to stop or end the webinar at the moment if there are no further questions arising. Thank you for being part of this kind of webinar.